Hi, Tom Walls, Carbide Processors. This is a thin kerf saw blade. The plate measures 0.069 inches to 0.070 inches thick. As you can see, it is not in great shape. This is another one. These were actually off of a gang rip in a truss plant in eastern Oregon. And they had a feeding issue. They overfed it, tried to cut two boards, and everything went to pieces. But anyway, the reason I'm talking about these right now is that thin kerf is often touted as a miracle cure for people with underpowered saws. As saw plate gets thinner, the saw gets less stiff. It gets weaker. It's more likely to deflect. If it deflects or bends, then you end up with this. You can end up with this. In any case, if it deflects or bends, you're going to end up with worse cuts. Everybody knows that. Not a secret. Pretty obvious, except for the fact that as saw plate gets thinner, the difference in strength, difference in stiffness, measured as strength or the other way around, decreases as the cube of the difference. So if you go from a 100 thousandths plate to an 80 thousandths plate, okay, you have 80%, I can't remember which hand was which, you have 80% of the thickness. What you actually have then on the strength is you have 0.8 for 80%, so you have 0.8 by 0.8 by 0.8, which is 0.512. As the saw plate thickness decreases by 20%, you end up with 51.2% of the strength, which surprised me. I, for some reason, thought it was a second order function or 0.8 by 0.8. No, it's 0.8 by 0.8 by 0.8 or 51%. So a 20% decrease in plate thickness means you end up about a 49% decrease in plate strength. That is it. Thin kerf is wonderful. We sell them. We sell great thin kerf saw blades, but you have to be aware of the difference in strength. Thank you. Bye.